Hi guys, on Exit Slip 510, our goal is to be able to solve some volume problems when there are fractional edge lengths. And we know to find volume of a rectangular prism, we just need to take length times width times height. Okay, so when I do this, guys, I notice, I've got fractions here. Now, I could change them into decimals. Makes it easier to do it on a calculator. There are some calculators that you can do fractions on too, and you have more advanced calculators. But we know the length and the width is 6 1/4 times 3 1/2. That would get us that bottom row, and then I need to take it times 4 to fill it up. And that's how we would find the volume. So we can do this several different ways. Again, if I was going to do traditional with fractions, I'd make these into improper fractions and take that times that, get an answer, then take it times 4. I think I'll probably just put it into a calculator since all of these fractions can become decimals. I know 1/4 is 0.25 or 25 hundredths. So to do that, I could say 6.25. We know 3 1/2 is 3.5 times 4. And I could just put that in on a calculator and solve that. Okay, or I could do it step by hand. But again, the goal is to find volume. So we're not going to worry about showing the multiplying. Let's do it on a calculator. And if we did this, guys, I'll write the answer down here. We would get 87.5 cubic inches to fill up this with inch cubes. 87.5 if I multiplied all these. Again, do a little estimating in your head. About 6 times 3 be about 18 times 4. We're in the 70s. And it's going to be a little higher than that because these were a little bigger than 6 and 3. So that answer makes sense down there. That really wasn't the new part. The new part was, how do I deal with these little fractional cubes? What if I didn't put full inch cubes in here? What if I had cubes that were 1/4 inch cubes and I wanted to fill them with those little tiny cubes? And this gets a lot more complex than most people think. A lot of people just think, oh, I just take this times 4 because, oh, they're 4 times smaller. But this is where some of us were getting tricked a little bit earlier, guys. If I draw out a 1-inch cube and I want little 1/4 inch cubes, and we know 1/4 inch cubes, divide these into 4 equal parts. So those cubes would maybe be about that small. How many of those fit in there? It's going to be a lot more than 4 times more. Okay, and what we learned was when I reduce with a cube, when I reduce it, the length, the width, and the height all get 4 times smaller. I'm condensing the length, the width, and the height all 4 times smaller. So technically, it's 4 times 4 times 4 times smaller. This little 1/4 inch cube is 4 times 4 times 4, which if we do the work there, it's 64 times smaller. Not just 4 times smaller like most people think. All right, so I could fit, in other words, 64 of those little 1/4 inch cubes. 64 of those 1/4 inch cubes fit into a 1-inch cube. Okay, and again, a little tough to see there. Scoot it over, give us some more room there. But 1/4, 64 of those 1/4 little inch cubes couldn't fit inside a 1-inch cube if I drew it up. Okay, so they are very, very small. When I reduce to a 1/4 inch cube, I reduce the length, the width, and the height all 4 times smaller. So it actually becomes 64 times smaller, those cubes. So if I were going to do it that way to find out how many 1/4 inch cubes, I could do 87.5. And that's 87.5 of those inch cubes fit in here. But there's 64 of those 1/4 inch cubes that fit in each of those. So I could simply multiply 87.5 and every one of those times 64. And I would come up with, if I did all the work, and I'm not going to show it, I'd use a calculator, I'd get 5,600, and that's right in that spot there, so I'll move below, you get 5,600 if you multiply those. And that would be my answer of how many of those 1/4 inch cubes. Okay, 5,600. Okay, so some people learned and understood it that way, that there's 64 of those little ones fit into every one. So we need to increase this 64 times greater. Now there's another way we talked about doing it yesterday. I could figure out how many little 1/4 inches fit across here. In other words, I'm taking 6 1/4, dividing it into groups of 1/4. How many 1/4 go across here? Again, I don't want to draw them all in, but if I understand division, how many 1/4 make 6 1/4? And if I do this, you'll come up with, and we can see that there are 25 of them. So this would be 25 1/4 inch cubes could line up in here. Again, if just real quick to double check that, I know if I make this improper, that's 25 fourths. Say it backwards. How many 1/4 make 25 fourths? 25 of them. So I could fit 25 little 1/4 inch cubes in there. And I could do the same thing here. Take 3 1/2 divided by 1/4. How many groups of 1/4 would fit across here? And if you take 3 1/2 divided by 1/4, you're going to get 14 of those little tiny cubes would fit in here. And then I have to do it again. How many 1/4 inch cubes would fit in 4? So 4 divided by 1/4, you'd get 16. Okay, so another way to solve this then could just be by taking, I'll go do it down here, 25 length times width times height. But do it with the 1/4 inch cubes. 25 times 14 times 16. So I could do 25 times 14 times 16. And if I do that, I can multiply in any order. And I'd use a calculator here, and I'd punch it in, and you will get 5,600 again. No matter which way you do it, you're going to get the same answer if you've done your calculating correctly. So some kids like one way, some kids like the other way a little bit better. Just use what makes sense to you.